are for our equivalent ratios. If we had A to B and we had C to D, how are we finding out if those two ratios were equivalent? How did we figure out if those two ratios were equivalent? Yeah, we called it the double V. And we had to multiply them by the lowercase c, which stands for constant. Very good. Okay. But today we're going to look at equivalent ratios defined through the value of a ratio. So today we're going to look at how ratios have a value. Okay? So let's take a look in our notes. Now, we have a statement up here that says recall, which means remember. We talked about different ways to write a ratio. If we write a ratio A to B, we can also write that as a fraction. So a ratio of 1 to 2 can be written as 1/2. You know, from elementary school, there are 4 different ways to write a ratio. With a colon, with the word 2, or you can write it as a fraction. Okay? Now, I see here the word quotient. Quotient? We're doing ratios. What does quotient even mean, and how the heck did it get into the middle of ratios? What does quotient mean? Yes, a quotient is the answer to division. Why would we be talking about division now?
Because the fraction sign is also used for division.
That's right. A fraction bar is another way to write division. So if we see 1/2, that's the same thing as 1 divided by 2. So the fraction bar means division. So on a ratio of A to B, remember B cannot equal 0, we call the quotient A over B the value. So when it's written as a fraction, that is the value. So now suppose I gave you 2/4. Okay, so we have 2 to 4. Yes? Can be written as 2/4. Is that really the value? Think about your knowledge of fractions. If I had a pizza and I ate 2/4 of it, what did I really eat? I ate half. Means the same thing, has the same value. So they're not equal, but they're equivalent. They mean slightly different things. So instead of saying 2/4, I can say 1/2. So 1/2 is the value of the pizza that I ate. Even though I ate 2 out of 4 slices, I ate half. So can we say that 2 out of 4 is equivalent to 1 out of 2? Can we say that those two ratios are equivalent? Yes, because they have the same value. That's pretty much our whole lesson. I just went ahead. So let's take a look at exercise number 1. Circle any equivalent ratios from the list below. Using the double V method. Okay, I apologize for the interruption. I don't know where we left off. But let's look at exercise 1. Circle any equivalent ratios from the list below. So does anybody see any equivalent ratios?
Yes.
What have you got for me?
1 to 2, 5 to 10.
Absolutely. Those are equivalent ratios. If we set up our double V method, what would my constant be? Times 5. Do we see anything else?
6, 16, 12.
Absolutely. Those are equivalent. And if I set up my double V method, whoops, what's my constant? Times 2. Okay, so we know those are equivalent ratios. Now we knew that. That's a flashback. We knew that. Now let's take it to the next step. let's find the value of those four ratios and see if we can come up with something. So what's the value of 1 to 2? How do we write value? We write value as a fraction. So how am I going to write 1 to 2 as a fraction? 1/2. Is that my simplest terms, or reducing? Those technically aren't the words I'm supposed to be using. It tells you here to rewrite the fraction using the largest possible unit. That's like new way of saying to reduce it or simplify it. I know, totally confused me when I first saw it. So now, what is the value of the ratio of 5 to 10? How do we write the value? As a fraction. So what is my fraction for 5 to 10?
1/2.
Oh, you just jumped right ahead. It's 5/10, but that's not how we want to write it. We want to write it as 1/2. But wait a minute. I can see that they have the same value. So if they have the same value, those must be equivalent, which is what we set up here. Let's take a look at the next. 6 to 16. 6 to 16. How would I write that as a fraction? 6 to 16, because the value is written as a fraction. What do you want to say? As what? 3/8. So that's the value, 3/8. What about 12 to 32? How would I write that? Exactly. 12 over 32. But
You could simplify by 4 and then 4/8.
3. Divide them both by 4. Right. Wait a minute. Don't tell me to calm down. Don't ever tell me to calm down. So I see here 3/8 and 3/8. So if the values are equivalent, the ratios are equivalent. You're awesome. This is why I came to school today. You're awesome. No, thank you. You're welcome. So at the bottom of your notes, you're going to copy this statement. We just proved, write this down please, we just proved the value of the ratio is the same for equivalent ratios. I'll read that again, especially for those of you who may not be able to see it. The value of the ratio is the same for equivalent ratios. And we just proved that. Here highlighted in yellow, both values are 1/2. So the two ratios are equivalent. Here, both values are 3/8. So these two ratios are equivalent. Okay, let's continue. So this just summarizes what we talked about. So if you look on your notes, you see it says here is a theorem. Has anybody heard the word theorem before? Well, a theorem is a statement that is always true. We just proved the statements. We just proved a theory. A theorem. Oy. Highlight the theorem in your notes. It reads, if two ratios are equivalent, then they have the same value. So we just sort of reworded what we just wrote. We found equivalent ratios and found that their values are equal. So if their values are equal, then the ratios are equivalent. So highlight that theorem. That's what we just proved. So let's look at exercise 3. I love this one for obvious reasons. You know, I'm a triathlete. I've done a duathlon. So Tavon is training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race. That doesn't mean that your one leg on the bike is actually longer than the leg that you run with, so you're not actually biking, you're running at the same time. But you can just walk in when I'm standing here doing this. So, what does that mean, the leg? What does that mean, the leg?
It's like an exaggeration for like, well, not an exaggeration. I can't think of the word.
It's like a name. It means that part of the race. So a leg means that part of the race. So whether you're doing the biking part or the running part, that's what they call the leg. Okay? In a triathlon, there are 3 legs to the race: the swim, the bike, the run. Okay. So when he's training, he rides his bike more than he runs. So during training, Tavon runs 4 miles. For every 14 miles, he rides his bike. So we're comparing running to biking. Identify a ratio associated with this problem and find its value. So we're looking for 2 things to answer this question. We have to make sure that we answer both parts. So first, what is the ratio? What is the ratio of running to biking? 4 to 14. But now we want to find its value. How do we write value? Value is written as a fraction. So I'm going to write it as a fraction. But is that how we want to write it? How do we want to write it? Yes, and that would be what? Yep. Right. So that's actually our value. 2/7. Let's see if he's consistent. So use the value of the ratio to solve this problem. When Tavon completing all of his training for the duathlon, it's duathlon day, he put in the work, he's ready to go. The ratio of total number of miles he ran to the total number of miles he cycled was 80 to 280. So we're still looking at running to biking. So the ratio of his total training was 80 to 280. So what is his value? 80 to 280. But we don't want to leave it like that. I could immediately divide them both by 10. Then I can reduce both. So the value of his total training is 2/7. So is it possible that this was his monthly total? Is that possible? Yes, because 80 to 280 is equivalent to 2/7. Why are they equivalent? They have the same value. That's right. So there is your answer to the question. This is possible because the ratio of the number of miles he ran to the number of miles he biked is 80 to 280. Has the same value, which is the same value as the ratio of 4 to the value of 2/7, which is the same value as the ratio of 4 to 14. We could always double check it like this. 2 to 7 was his ratio. His total was 80 to 280. We could always double check using our double V. Times 40 times 40. That's a constant. So those are equivalent ratios. So to summarize today's lesson, another way of finding equivalent ratios, instead of using double V, we can find equivalent ratios by looking at their value. And value is written as a fraction in simplest terms. So if two ratios have the same value, then those ratios are equivalent.